Everyone, my name is Shaira May Peñas, and today in this video discussion, I will show you how to solve a problem using the Broglie's wavelength equation. But what is the Broglie's wavelength equation? Based from the famous physicist Louis de Broglie, he showed that the wavelength is equal to the Planck constant divided by the mass times the velocity. In using this formula, we should always keep in mind that the wavelength has a unit of meter, the velocity has a unit of meter per second, the mass is kilogram, and the Planck constant is joules second, or kilogram meter squared per second squared second. Now, let's proceed to our problem. The problem is an electron of a mass 9.11 times 10 raised to negative 31 kilogram moves at nearly the speed of light using the velocity of 3 times 10 raised to 8 meter per second. And our task is to calculate the wavelength of the electron. Okay, the first thing we must do here is to find the given quantities or variables, which is the mass and the velocity as well as the Planck constant. Based from the problem, the mass has the value of 9.11 times 10 raised to negative 31 kilogram, while the velocity is 3.33 times 10 raised to negative 8 meter per second. And the Planck constant has the value of 6.63 times 10 raised to negative 34 joules second. Let's apply the Broglie's wavelength equation, which is lambda is equal to the Planck constant, which is 6.63 times 10 raised to negative 34 joules second, divided by the mass, which is 9.11 times 10 raised to negative 31 kilogram, times the velocity, which is 3 times 10 raised to 8 meter per second. But before we compute those numbers, let us first change the unit of the Planck constant from joules second into kilogram meter squared per second squared second in order for us to easily get the unit that we need, which is the meter. Now, let's compute the numbers, which 6.63 times 10 raised to negative 34 divided by the product of the mass and the velocity, which is 2.733 times 10 raised to negative 22. And the answer is 2.425 times 10 raised to negative 12 meter. Now, we can conclude that an electron of mass 9.11 times 10 raised to negative 31 kilogram that moves at nearly the speed of light using a velocity of 3 times 10 raised to 8 meter per second has the wavelength of 2.425 times 10 raised to 12 meter. And that's all for today. I hope you learned a lot from this discussion. Thank you and keep on loving physics.